Okay, guys, so our last one that we're going to draw is convex mirrors. Okay, so convex mirrors are the most difficult to draw, but the good news is every single convex mirror behaves the exact same way. Okay, so if you can figure it out, it's always true for convex mirrors. So let's draw one. Okay, take your straight edge. Okay. And convex goes the other way. Okay, so our mirror is still over here. Okay. Now I'm gonna put my object over here. Okay, now everything over here is inside the mirror. Okay, here's the key to convex mirrors. The focal length is always negative, meaning the focal length is here, it's virtual. Okay, it's always on this side of the mirror. So here's my focal length. Okay, it's always negative for convex. Remember, every time you do a convex mirror, it's going to behave the exact same way. Okay, so we're going to draw the same lines. Okay, now, first one we draw, parallel. Okay, hits my mirror. Then, okay, it has to bounce backwards because that's what mirrors do, they bounce things backwards. So I'm going to line up my focal point and the end of this red ray. Okay, so I'm going to line it up, and then it's going to bounce backwards. So it comes here and then bounces backwards. The next one, through the focal point, then parallel. So I'm going to line up the top and my focal point. Okay, I'm going to draw my line until it hits the mirror, because once it hits the mirror, it bounces back and goes parallel to my principal axis. Okay. So just to review, the red line, parallel, bounces backwards, upwards. Blue goes towards the focal point and then bounces backwards. Now you'll notice here again, they do not intersect. And because of that, we are going to need to draw the reflected rays backwards to the right side of this mirror. Okay, so for our red line, okay, you're going to take this reflected ray, the reflected ray is the top one, take it, and you're going to bring it back, okay, to the other side of the mirror. Dotted line, make sure it's dotted on our right side. Then our blue line, our reflected ray, is the one that's being bounced back. So it's this one. You're going to line up and draw a dashed line here. And now look, they intersect. Okay, they intersect right here. Okay, so this right here is my image. Now, a couple things about my image. It's smaller. It will always be smaller with convex. Okay, smaller. Okay, it's upright. You'll notice it's in the right direction, upright. And the other thing, it's virtual. Whenever you have these dotted lines, it's virtual. So for no matter what, your convex mirror, smaller, upright, virtual. Okay, now let's do the math. Okay, you're still looking for DI and magnification. Okay, so let's say our object distance is, 15 centimeters. Okay, and our focal length is always negative for convex, is negative 20 centimeters. Okay, I want you to find DI and magnification. Pause the video and then find them, okay? Okay, don't forget to cross multiply. DI becomes negative 8.57 centimeters. This negative means virtual. Magnification, okay, is negative DI over DO. So our magnification is 0.57. Now, if magnification is positive, it means it's upright, which it is. And if this number is less, absolute value is less than 1, it means it's smaller, which it also is. Okay, so I'm going to be posting all of my lecture notes This is the exact same thing I just went over, but in case you want to see it again or you want to see the math a little bit more detailed, please look at this, okay? There are more pictures, exactly what I drew, okay? So please look at this. Your work today is to just do these drawings and do some of this math, okay? So keep that in mind. Please, please, please let me know what questions you have, and good luck.